Hello friends, and welcome to this video today. In this video friends, we shall be looking at this question from the 2020 MIT B qualified exam, guys. It is a test for the people who want to participate in the 2020 MIT B competition. And guys, it is 20 questions were given, and you have to answer all the 20 questions for 20 minutes. So friends, stay tuned and watch the video from start to finish, because at the end of this video, guys, you shall discover so many hints and tricks that could help you to solve all your integrals for you. So friends, all the questions were based on integrations, and you have to integrate, like I said, 20 questions for 20 minutes. So friends, for a quick reminder, if you're new to our channel, don't forget to hit that subscribe button looking at you, and please press the like button, because that is going to motivate me, guys, because I took quite a lot of time to prepare to come and present the solution for you guys. It took me quite a lot of time. So friends, the only way you can appreciate the time I took is by liking the video and subscribing if you've not done so, and sharing the video with your friends. Let's get started, friends. Great. So friends, I have the question on screen, as you can see. So friends, I see that I have the integral going from 1 over root 2 to 1. Then I have arc sine x over x cubed dx. So friends, keep in mind that arc sine x is the same like sine inverse of x. Good. So I see that x and that's x cubed and arc sine x, guys, they are not too related. Okay, they are not too related, but they somehow we can make both of them to be related. Okay, so so guys, what we are going to do is that we are going to do a u sub. Okay, we'll do a u sub because that is the only way in which we can actually produce an x from this arc sine x. So guys, we are going to do a u sub. We are going to let u to be arc sine x or sine inverse of x. If we take the original sign on both sides, friends, we are going to have our x to be the same like sine u. Differentiating to get the x, we are going to have the x to be the same like cos u du. Good. So friends, now we are now going to change the limits of integration. So we are now going to have our table in this form. We need the x values and we need the u values. Good. So friends, we need the value of u when x is 1 by root 2 and when x is 1. So we have 1 by root 2, then we have 1. Good. So when x becomes 1 by root 2, guys, if we will simply put it here, right here, that therefore means that sine inverse of 1 by root 2, guys, that therefore gives us what? Great, it gives us pi over 4. Good. So if we put our x equals to 1 now, if we put it into where we have sine inverse of x, we put it here, we're going to have sine inverse of 1, guys, which gives us what? 90 degrees. In other words, guys, pi over 2. So we have our pi over 2. Yeah, great. So now we are ready now to take the integral from the x world now to the u world. Great. So now we are now going to have now, guys, the integral of when x was 1 over root 2, our u was what? Pi over 4. So we have pi over 4 here. Likewise, we have pi over 2. Then guys, our arc sine x, as you all know, guys, was what? Our u. Then our x cube, guys, we never had an x cube here, right? So but we can produce an x cube by simply taking the by simply raising everything to the power 3. So we're not going to have x cube to be equals to sine cube u. That's why we have the sine cube u here, guys. Keep in mind that our aim of doing so is that we don't want to have x in the u world again. We want to isolate the x and have everything in terms of u, because x is not invited in the u world. Great. So friend, then our dx was what? Cos u du. Great. So if we clean things up now, we are going to have the integral going from pi over 4 to pi over 2 of u cos u all over sine cube u du. So friends, at this point in time now, we are going to be using the integration by parts, and we are going to use the DI method. That's the shortest method. That's the shortest summary of the integration by part method. Okay, it's a summary. You see that, guys, it's going to work out so nicely. Great. And we are going to be differentiating u and integrating cos u over sine cube of u. The reason for doing so is that, guys, we can differentiate u and put that to 0. Okay, once we can differentiate and put that to 0, it's a good hint for us to differentiate u. Then now, guys, we can actually integrate this guy, right, by simply doing a u sub, by simply doing a substitution, and we can see how we can finish that. So friends, we are going to have our di set up in this method. We are going to have our di. Then guys, we need a sign. The signs alternate from positive to negative and comes back to positive. Good. If we need more columns, we still continue in that same pattern. Here it's going to be negative, but in this case, guys, we need two. We need a positive sign, negative and positive. That's all we need. So like I said here, guys, we'll be differentiating u. So we're going to have our u. They will be integrating cosine of u over sine cube of u. Good. So this is how we are going to do it now, guys. So that if we differentiate u, we are going to have what, guys? 1 time again. Differentiating 1 again, guys, gives us 0. Good. This is what we wanted to see. That's what we wanted to see, guys. Then now if we differentiate cosine of u over sine cube of u, guys, let's investigate this. We cannot see if we can get it clearly, right? So now, friends, let's investigate that. Let's investigate what the integral of cosine of u over sine cube u will look like. So guys, let's investigate it here. Let's arrange everything and investigate. Great. So friends, let's be looking at the integral of cosine of u over sine cube u du. So guys, if we do a substitution, let's take v. If we let our v to be the bottom, that is just sine u, not sine cube u, guys, just sine u. If we let our v to be sine u, such that the v, guys, differentiating v gives us what? Cosine of u du. Good. So now, guys, if we replace everything now, we have our cosine of u du, guys, is simply what we have at the top, right? It's simply what we have at the top. So in other words, we are simply going to integrate 1 over v cubed dv, right? So if we write this 1 over v cubed dv as v raised to the power negative 3 according to our law of indices, we have the integral of v raised to the power negative 3, right? Add 1 to the power gives us negative 2. Divided by that, we are going to have negative 1 over we are going to have negative 1 over 2v squared, right? So we're going to have negative 1 over 2v squared. But guys, what is our v? Our v was sine u. So everything now turns out to be negative 1 over sine squared of u. Great. But guys, what is 1 over sine squared u? Great. You guess it right. It is nothing else, guys, but cosec squared u. Good. So we're now going to have negative 1/2 cosec squared u. Great. So guys, we'll just put our value here that the integral of this guy now is simply going to give us negative 1/2 cosec squared u. Great. Then now, friends, if we integrate this guy again now, let's note here, guys. Let's have a note here. Let's have a note. It keeps on coming, guys. Let's note that, guys, that the integral of negative cosec squared u, guys, integral of negative cosec squared u, that therefore gives us what? Positive cotangent u, or positive cot u, the short form, guys. So we are now going to have positive cot u. Then the 1/2 comes down. We have 1/2 cotangent or cot u. Great. That therefore implies, guys, that the integral of this guy now, turns out to be, now we multiply these diagonals. We multiply this guy now. We are simply going to have negative 1/2 u cosec squared u. Then now multiplying these other diagonals again, guys, multiplying negative 1 and 1/2 cot u gives us minus 1/2 cot u. Great. Then, friends, if we multiply 0 and 1/2 cot u, it simply gives us 0, right? And therefore means that we are integrating nothing. Okay, so we simply forget about it, guys. If we're not going to bring for this guys now, that therefore means we are just going to have our answer as negative 1/2 u, then cosec squared u minus 1/2 cot u. Great. The limits are from pi over 2, from pi over 4 to pi over 2. Great. So these are the limits of integration. So if we plug in pi over 2 here, guys, we are going to have negative 1/2 pi over 2. Then, guys, what is the value of cosec squared pi over 2? Keep in mind, friends, that from here we know that cosec squared is something like what, guys? 1 over sine squared, and sine pi over 2, guys, is what? 1. So this simply gives us what? Just 1, right? Gives us just 1. So then if we plug in pi over 2 here, guys, you see that cot pi over 2 is going to be 0, because We know that that cot u is the same like what, guys? 1 over tan u, and tangent of pi over 2 simply gives us what? Infinitive, and the limit of that is 1 over the infinitive, guys. It therefore approaches 0. So we are not going to have this negative 1/2. Our u is pi over 2. We have it here. Then since cosec squared of pi over 2 is simply 1, then minus this quantity gives us 0, because 0 times 1/2 gives us what? 0. So we have the 0 here, minus 0. Then now, guys, if we plug in pi over 4 here, all we are going to have is simply going to be we have negative 1/2 pi over 4. We have, that's minus into, we have negative 1/2 here. Then here we are going to have pi over 4. We have pi over 4. Then cosec squared pi over 4, guys. Keep in mind that sine pi over 4 is given as what, guys? 1 by root 2. So if you square that now, guys, if you square that, we are simply going to have 1 over 2, right? Great. Then now, since it is 1 over sine that, we simply reverse it. So we're now going to have just 2 here. Alright, we're now going to have 2 here. Then minus, if you plug in pi over 4 here, you're going to have pi over 4, right? But cot is what, guys? 1 over tangent, and tan pi over 4 is simply 1. So 1 over 1 simply gives us 1. Then times negative 1/2 gives us minus 1/2. So now you see that this 2 and this 2, they will cancel. We are going to have negative pi over 4 the inside, negative pi over 4, then this negative here. So this negative over 4 will cancel with this positive pi over 4 here. Then this negative and negative 1/2, they will simply just multiply to give us what? 1/2. Great. So we just have 1/2. So friends, this is the answer to this our integral. So guys, I hope you found the video so useful, guys. If you found the video useful, don't forget to like the video. That is your own gift to me, guys. It took me quite a lot of time to prepare this content for you guys. It took me quite a lot of time. So please appreciate me by simply giving the video a thumbs up, and subscribe to the channel if you've not done so that we can have so many subscribers to join us. Thank you very much, guys. I wish you so well in your calculus exam and in other exams, your GC exams, other exams you're writing. And feel free to reach out to me if you have any issue. I'll put the link to my WhatsApp contact in the description for your convenience. Thank you very much, guys, and have a blessed day.